To introduce the JC course experiment because it has a lot of importance. This is actually a first video.
Sir, will you tell a bit about yourself, sir, what you do and
I am Professor M.A. Hadid, Professor in Hafunda Engineering College, and working since 25 years there. I've done a lot of research and paper publications. We have been working with the now presently head and professor. And recently, that means 1.5 years before, IEEE approached us for making the exact replica of the JC course experiment. Actually, this is the first experiment in communications. The communication has started, or the radios have been started only because of this experiment. And not only that, the electronics, concept of electronics is also started with this experiment only. But the way of popularization was not there. So JC Bose has the first Indian scientist or Kolkata scientist there. He is a practical physical physicist from India. He has designed so many instruments. One of that is this experiment. Other than that, one point contact receiver also he has designed. Point contact receiver is nothing but a diode. The diode was not there that time. Then afterward it has the name has come as a diode. Actually the actual electronics program or electronics field has started from this experiment only. Actually all the credit should be given to him. And this experiment in those days, that is JC Bose experiment, millimeter wave experiment, production of the millimeter waves in those days was very difficult. In spite of that, very simple instruments like two rods, that is electrodes, and one spring, he could be able to generate the millimeter, that is 60 gigahertz frequency range, and could be able to receive it also. So he has generated these millimeter waves in 1880s and demonstrated this in Calcutta there, and afterwards he has demonstrated in Royal Society of London. But while returning, he has lost his receiver in ship. 1 year afterwards, the Marconi has published the result and he has got Nobel Prize. Actually, it is not like that. The JC Bose has a designed instrument and he has first time demonstrated it, but as sir said, he has not published the result at that time. After that, with the help of some of the others, he has patented it afterwards. But by that time, he has already the Marconi has already got the Nobel Prize. But Marconi's grandson came to the Calcutta there. He has written in the visitor's book. Actually, JC Bose was the pioneer of this one. He should be honored. He has written it. So, actual Nobel Prize should have been given to the JC Bose. So now, the IEEE, after a long time, that is in 2012, has recognized at least to pay the homage to the great scientist. They have recognized this experiment as a milestone experiment because it ignites the minds of the all young fellows. It gives the inspiration to the all young. Even one or two gets inspired with these instruments, what we Indians have done. Definitely it will be a revolution to the young societies. So now after this IEEE recognition, that is a milestone experiment, they have approached different organizations. Even Calcutta, there is a JC Bose Institute. Nobody has taken up. Then after other institutes also they have approached. And afterwards it has come to us. Then we said then it's a challenging one. Because we have to design this experiment like 120 years before. We have to go to the 120 years before, and as per that components only we have to get it and design it and get the practical working model. So it was a very difficult one. Then in spite of this lot of difficulty, we have accepted it. Then we have thoroughly done the literature survey. A lot of parameters were missing. Only what are the only components here? Only springs and two rods and one battery. With this, we have to generate 60 gigahertz frequency and receive it. And what are that you have designed it again? You have to do by modern techniques. We have used the other in RCA. Modern equipment we have taken up. With that also we got the graph of it, measured it, and that graph is also there with us. So now lot of difficulty we could able to design that, but the total credit was not given to the receivers. Yes.
How do you know this frequency was 60 gigahertz? Was it mentioned at that time?
No, he has designed it. He has mentioned that we have produced 66 gigahertz or 5 millimeter waves. He has mentioned it. So now we want to produce the same again. One paper was there, in that he said that it was 5 mm or 60 gigahertz. So now we want to produce it and show that one of the scientists from Washington University, he said that he has not designed. He did not get 60 gigahertz. So then I said, now if it is not there, then we will prove it. He has published the result also and said that he has not designed, it was not possible in those days. So now he has not designed, he did not get 60 gigahertz. Then I said no. By chance he came to the Birla Science Center in one day, after my designing and all this, after measuring the frequency in RCA also, we have the proof for that measurement also. He came to us and we were discussing it, photograph also I will show you. Then I have said, you asked me the question, how he has that not designed? Then I have proved it that this is the instrument, with this we got 60 gigahertz, with this modern equipment, then we have shown it. Then he has accepted that definitely he has designed it. Now when he has designed it, he should be honored then. So now for designing of this JC Bose experiment, we have done lot of survey there, lot of instruments. Then we have started from the small wire. The wire should respond to the signals at 60 gigahertz that too. And electromagnetic radiations it should respond. Then previously for 6 months we did not get anything. One day we got with one compass some changes. In the beginning we were just putting that radiator here, this is a radiator and that is a receiver. Radiator 2 rods from battery only. With these 2 rods and a battery, we have with the help of the battery and one coil, we have produced up to 1100 volts. And that is discharging through this and producing this electromagnetic waves. Then whether it is producing that, we were not sure. Then we have taken only a compass and then we have checked it totally. Once we got this small deflection. Then once we got this just deflection, then we have shifted it to the ICs, LEDs. Then we have put one LED and circuit. Then LED has grown in. Then when LED has grown, then we have come to the actual instrument. Then we have improved it. Then experience improvement. It has taken 2 years. Then that's the only thing was that when the Indian has done, then we should be respected. Then we should be proud of it. That then definitely he has produced it and then he has received it also. So now please you go through that instead of going in details of this one. Small in details I have given it. I will show you one video there afterwards. I will explain, demonstrate, it's a working model, nowhere it is available. In America there is one science museum also. They are also asking us, sir said now, we are going to produce more also. There are 2 models in that is Birla Science Center, one here, and some more models we are going to give for the IEEE as well as to the Science Museum in Washington also. So we want to propagate it and tell the facts so that our Indian minds will grow or it gets ignited. Even one gets ignited, it will be a revolutionary change to the India. So now, please, this is only a simple thing here, a radiator and a receiver. Springs and a rod. First, please, you see the video there. Afterwards, we will show you how is it working. Right? Please.
He was a popular teacher and an outstanding researcher. His research covered many areas, including properties of materials, electromagnetic waves, and even plant physiology. He was knighted by the British Empire in 1917 and was the first Indian to be elected Fellow of the Royal Society in 1920. Frequency spectrum extends from voice frequency signals to visible light and beyond. Millimeter waves are a small part of the frequency spectrum. In 1895, Bose demonstrated the generation, transmission, and reception of electromagnetic waves at millimeter wave frequencies over distance of nearly 1 mile. Marconi in England and Popov in Russia were conducting similar experiments at that time to demonstrate wireless signaling, but their experiments were at much lower frequencies. In 1895, public demonstration by Bose in Calcutta predates similar demonstrations of wireless or remote signaling by Marconi in 1897. At the invitation of Lord Rayleigh, Bose demonstrated his millimeter wave experiments in 1897 before the Royal Society and other learned institutions in London. Bose received a United States patent in 1904 for the discovery of a class of semiconductors detectors and iron-mercury-ion coherence for electrical disturbances and other similar radiations. Further research and development at millimeter wave frequencies was almost non-existent for the next 50 years. The pioneering work of Jagdish Chandra Bose was at least these many years ahead of his time. The components developed by J.C. Bose in Calcutta, initially at millimeter wave and later at microwave frequency, were outstanding discoveries made more than 100 years ago. Most of these are used in modernized forms for Earth and space wireless links and remote sensing. The IEEE milestones in electrical engineering and computing recognize technological innovation and excellence for the benefit of humanity. Each milestone recognizes a significant technical achievement that occurred at least 25 years ago in an area of technology represented in IEEE. In September 2012, IEEE recognized this classic experiment of Jagdish Chandra as an IEEE milestone.
So this is the video, how they, what are the, so all this is our video, who has encouraged us for taking up this project there. It was a challenging project for us, because if you don't do this, you would have lost, or they would have lost the aim and game, so that's why it was a challenging task for us. So, most of them, the others, they have supported us. So these are the team members who helped us, who are sitting there on parties. We are continuously reference what we have been doing with us. And one Elias here, and he also helped us out. They did not get discouraged because of even not getting the results. One stage has come. By designing that we were not getting anything, we were thinking of to run away. Why did we take this? That stage has also come. In research it will come easily. So I said, don't worry, that stage will definitely come on our other, but we have overcome this. So because of continuous efforts and continuous literature survey there. So morning to evening, even while paying also we used to think this. There, because it was the prestige to the college as well as to all of us. So therefore we want to prove this, so therefore continuous efforts we made in this. So this is an image.
About 60 gigahertz frequency with an electrical spark between a sphere and two concentric
This
hollow
is a
hemispheres.
radiator there. located.
a 12-volt
As we
battery
press it,
and a circuit.
the signals will
At the
come
heart
there,
of these experiments,
and the read, and what are that signals are falling can
measuring
be
frequencies as
seen in
high
the
as millimeter waves.
animator there.
Wavelength of electric radiation
And
was determined by using curved
the
gradients.
frequency can also be measured with the help of the grading
Was
there.
used as the
So that is
transmitting
the next one for
A
frequency measurement.
spiral spring receiver.
That is measuring the dispersion.
Pressure is finely adjusted
Actually,
to its
measuring
dispersion.
sensitivity.
So it's the angle, diffraction angle.
Diffraction.
Diffraction angle. So this is the receiver there. So receiver is simply on its springs and that is the receiver.
Parents, instruments did not exist for measuring frequencies as high as millimeter waves. Wavelength of electric radiation was determined by
This
using
is the
curved
angle measurement
gradients.
there.
An open-ended waveguide was used as the transmitting antenna. A spiral
In those days there were calling only pipes
pressure.
and antenna. All these pipes and nothing but antenna, waveguides and antennas.
Waveguides and antennas.
Presently it's waveguides and antennas. Otherwise they are calling in round pipe and this rectangular pipes. This is the receiver there. In that only 2, 3, 4 springs are there. Especially we have brought it by lot of difficulty. We could able to get the springs from Secunderabad from store. Almost all the stores we have searched for this. Pass on the springs now, the contacts will come there. It will generate the contacts. With that it will act as a diode there. So it was very difficult to pass through the. As you press it, it will be.
Sensitivity was used.
So now this experiment will give the concept of electronics
A working
and the total diodes and wave signal transmission without medium, and other than that the concept of mobiles and radios and communications. So lot of things are there in this experiment. The simple springs and this he has demonstrated lot of principles.
61
So this is the first experiment of all kinds. So he should be actually respected. So in that one, so many dignitaries have visited this experiment. We have demonstrated to so many scientists there. So this is Parali Birla Science Center in charge. I have satisfied. These are the dignitaries from other countries. So they were visiting in the Birla Science Center there. So this is the team with the Kodari sir. And our mentor there, our director. It looks very simple. Just press it, signals will be coming, but lot of scientists give scientists will not be, as you know it. And
Yeah, first let us see the demonstration,
Ah,
then
yes, sir.
subsequently people will ask questions.
this guy, you want to see?
Please, you can be at the table, sir.
So, but it will take time to go to the original question. Because
One second.
this once.
One second.
Old instruments are that time only gets magnetized, so it gets time for demagnetization. It gets time for the demagnetization. After demagnetization, again it will act as a magnet. So it will take slight time for the.
Slightly reduces.
All the four papers they have published this, and tomorrow also in Birla Science Center one more demonstration of this experiment is also there in Birla Science Center tomorrow.
Why don't you study the Indian Science Congress which is coming in Bombay?
Yes, yes, sir.
Sir,
No, we want to popularize it because this.
I am coming for Calcutta.
Right.
Every year celebrate for this